Students, we're going to work on our Introduction to Scientific Measurement 2. Anything you can do, I can do better. It's kind of a cute little, thing. This gets pretty competitive in lab, this particular lab, because we're seeing like who's the strongest grip strength. So anyways, that's why we named it that. So we're going to be talking about variables. We're going to design a good experiment, choose what we're going to be measuring and trying to correlate with grip strength. So how strong can you grip this sensor that we have on the computer? But first we want to talk a little bit about correlations. So I have 6 graphs up here. And as it says on your lab, the following graphs have correlations of 0, 1, -1, 0.7, -0.3, and -0.7. So try to guess which is which. So a correlation of 1 means like a perfect correlation. As 1 increases, the other increases in the same amount each time. Or as 1 decreases, the other one decreases at the same amount each time. So these would be correlations of 1, the increases and increases at the same time, or -1 when they decrease at the same time. So looking at a correlation of 1 and -1, which 2 graphs show like a perfect fit? As 1 increases, the other increases at exactly the same rate. So you've got a straight line where the data points fall on a very nice line. Or a -1, which is a negative correlation. So looking at this graph, this is a correlation of 1. In this lab, you're going to be making graphs of some data, and you're going to be telling me what you think the correlation will be. First, you're going to pick variables that you think would have an effect on how strong of a grip somebody has. And then gathering the data, and then graphing the data to see what does the data tell us. So a correlation of 1, this graph would be a perfect correlation. As one variable goes up, as one measurement goes up, the other goes up, and we've got a perfect line. This would be a -1. If that's a 1 and that's a -1, let's see the one that's kind of a 0, where there just seems like the data is scattered. There's no correlation. There's no real relationship you can see with the data. Which one looks like a 0? This data is just scattered all over the place. So this would be a correlation of 0, where there just doesn't seem to be any relationship between what we end up with. Let's look at the 0.7. So the 0.7 would mean that, yeah, there's a good correlation, but it's not quite perfect. But there is some correlation between the data, and that would be this one. -0.7 here, and this would be the -0.3. So again, we're going to design an experiment. We're going to carry the experiment out. You're going to graph the data, and you're going to see, is there a correlation between different variables? So let's look at what differences might you expect in grip strength for a given individual and for groups of individuals within the class. List them below. So I want you to think about what might affect how someone can grip something. I had a tennis player in this class once. My goodness, their grip strength was off the charts. Not a huge guy, but gripping that tennis racket and hitting that really hard, developed these muscles extremely well, and they had very high grip strength. So things like that is what I'm after here. I also had a student who had been in a car accident and had ruined their hand. Unfortunately, they could hardly grip that thing because of an accident, because of damage. So why don't you list 3 or 4 other things besides, are they a tennis player, or did they have something that affected their grip strength, in an adverse way? Think of things that might affect how you can grip things. So then typically in the lab what we do is each table comes up with 2 factors that they think might affect how strong someone can grip. And then we put all those factors on the board, so we end up with 10 factors because we usually have 5 tables of students. From those 10, we vote on our favorite 4. So that's why it says list any 4 variables you think might be correlated either negatively or positively. And then the class picks their 4 favorites, decides what they're going to be measuring, what units they're going to use. Let's say they used how big your hand is. So you have to decide, are you going to use centimeters? Are you going to use inches? And then you have to decide how you're going to measure that. So from the tip of your middle finger to your wrist, or were you thinking across the palm? So that's what this particular table is for. Once we come from our 10 ideas, like people pick age, or they pick how much you exercise, or what sports you play. There's lots of different ideas people come up with. We decide on 4, then we discuss, okay, how are you going to measure those 4, and how are you going to, what exactly are you measuring? If you're measuring, how big someone's forearm is, you have to decide exactly where are you going to measure on the forearm. Are you going to measure, at the elbow or 2 inches from the elbow? So you got to kind of come up with some very, very precise. Because in science, we want to make sure that our data is reliable, and we want to make sure that, if everyone measures a different distance for their forearm, it's not good data. Okay, that's what this is about. So now, the next thing that we do is we collect the data. And we've got a little demonstration with 4 students who came into the lab to show how that data collection happens. We use a sensor, they squeeze it, and it's measured, and then we get that data. Okay? We use the dominant hand, which would be the hand that you use the most, either right or left. Some people are right, some people are left. Do you know there was a time in history in the good old days when someone who was left-handed was actually beaten until they went to their right hand? I mean, people talk about the good old days, but honestly, there was a lot of bad things happening back then that kind of get swept under the rug. Anywho, dominant hand, non-dominant hand. Each person would take a measurement in newtons on our little grip strength. And I'll have a demo of how that happened. Of course, we're not doing it because we're not here. Okay? And then these would be the variables that applied to that person. Okay? So what I have prepared for you is we have got some data from other classes. We've got the data sheets from some other classes, and that's what you're going to be using. This class settled on the hand in centimeters, the wrist, and there's no way that the hand was 185 centimeters. I guessed on that, and I guessed wrong. They must have been measuring in millimeters. Okay. The age was in years, and the height was in meters. These are the 4 things that this particular class decided they were going to use. These are the 4 variables on that sheet. They had a discussion. They started with 10. They whittled it down to 4. They decided on these 4. So what we're seeing is there a correlation between these variables and the data? Okay, we're going to get some data here on grip strength here. I'm going to press collect. And our subject is going to squeeze as hard as she can for 10 seconds. Very good. And go ahead and stop. Okay. So now we're going to get the amount of newtons that were squeezed at. So we're going to go from 4 to 8 seconds. And we're going to click on the statistics button up here, and that's going to give us, we're going to go with the mean, and the mean is 94.59 newtons. So that is the measurement for this student. A female student, 94.59 newtons. Thank you. Now we're going to do our non-dominant hand. And so the same student is now squeezing with their non-dominant hand, which is, in this case, the left hand. Go ahead and stop. Excellent. We're going to again take the measurement from 4 to 8 seconds. We're going to take the average and that go up to statistics. And with the non-dominant hand, the mean is 82.65 newtons. Newtons is a measure of force. Okay, so thank you very much. Okay, now we're going to erase these, and our next subject is going to come. We're going to clear the latest runs, and we're going to get rid of these and start all over. Okay, so go ahead and pick up the, and is this your dominant hand?
Yeah.
Okay, so we're going to do the dominant hand first. And go ahead with collecting, and we're going to squeeze for 10 seconds. Very good, thank you very much. And now we're going to do our 4 to 8 seconds again. And get that measurement from 4 to 8 seconds. We'll go to our statistics, and the mean 122.7 newtons. 122.7 newtons, and this is with the dominant hand. So now we're going to collect with our non-dominant hand, which in this case is the left hand, and we'll start collecting. And go ahead and stop. Okay. And the mean here, 92.70 newtons. Thank you for helping out here. So now we've got another student coming up. So we're just showing you how the data was gathered. So we are going to be, so normally you students would be doing this, and we're going to clear that latest run, and so now we have another student. Which is your dominant hand?
My left.
Good. So we have someone with the dominant hand who's their left hand, and we're going to go ahead and squeeze that with their left hand, and this is the dominant hand. And so we will stop, and we will get our data from 4 to 8 seconds. And we will look at our, whoops, why did I do that? We'll get our data from 4 to 8 seconds. Then go to our statistics. And we've got a mean of 110.2 newtons. And now go ahead to your non-dominant hand, your right hand. Okay, we're going to collect. And go ahead and squeeze that. And okay, go ahead and stop. And let's look at our 4 to 8 seconds here. Oops, I keep doing that. And let's go to statistics. 1 to 2, 109.8. So both hands about equally strong. Thank you so much. All right. And we've got one more subject. And we're going to do this one. And we're going to clear this latest run. So this is what you would be doing if you were in lab, but we're using some nice volunteers. Now, is this your right hand, your dominant hand? Okay. Let's go ahead and collect. Okay. And we've got, go ahead and stop. Okay. And let's get our, let's get our average here. And I happen to know this person works with their hands a lot. So I'm guessing it's going to be a very high number here. Mean of 251.1. So 251.1 newtons. So that is the measurement there. Let's clear this one out and get a fresh run. And again, you would be sitting here with the class doing this particular. We're going to do it with the non-dominant hand now. Go ahead and collect. Holy cats. Okay. This person works with. Alrighty. We can stop. And let's see what we've got for the mean here, which is 250.5 newtons. Thanks a lot, students, for your help. Just showing you how we get that data that you're going to be working with. Okay. You're going to be in groups of 4. Each person in your lab group is going to graph one of those variables that I just showed you. The hand, the wrist, the age, whatever the fourth one was. You decide, you're going to make a graph of that data. We've got the data separated into males and females. You're going to graph the dominant hand data. Okay. When you do a graph, you want to make sure that your graph is well done. You want to make sure there's a title. Grip strength for age. Grip strength for wrist size. Force versus wrist size. You are going to make the graphs. Now, you're going to then look at the graphs and see if you notice a correlation. Remember the correlations from before. You're going to see, do the graphs that we made have any relationship or do they show any kind of correlation between age and grip strength, or between the wrist size and grip strength? So there's 4 graphs. You're going to look at those graphs. Do they relate to this correlation? That is what you're going to look at. The female data. You're going to look at the male data. You're going to analyze it by looking at it. All 4 of you, you need to share that with your table mates, with your group. So in this lab, we work in groups of 4. So you're going to work in groups of 4. You're going to look at each other's graphs. You're going to see, is there a correlation? And you're going to analyze it and talk about it. Now you're going to see if there statistically was a correlation in the data. Those numbers are going to be available at the bottom of the data sheet. We did some Google Sheets, which does some analysis and shows you the correlation numbers. So you are going to talk about each thing. Remember, each of these variables has its own graph, and you're going to analyze that data. Last thing you're going to do is answer a couple of questions. And there's a little thing at the bottom that talks about grip strength and how the medical profession uses grip strength and certain factors. So basically this lab is, as a group, you chose some variables, you got some data, you graph the data, you analyze the data, and you answer a few questions about the data. That's the whole lab. I'm providing data sheets from previous lab sections. I will put that up in your lab section, and that's the data you're going to use. Unfortunately, we can't come to campus and get the data, so we're going to use data from previous lab sections. Have fun on Intro to Scientific Measurement 2.